There is an animal the size of your finger that can throw a punch faster than you can blink. Not a little faster. So fast that the water in front of its fist boils, flashes with light, and cracks like a tiny gunshot. So fast that scientists needed special, high-speed cameras just to see it happen at all. It does not have venom, it does not have size, it does not have teeth worth talking about. It is a small, brightly colored creature most people would mistake for a pretty shrimp in a reef tank. And it carries one of the most violent weapons in the entire animal kingdom, built into its own arm. We call it the mantis shrimp. And the strange thing is, it is not a mantis, and it is barely a shrimp. What it actually is, when you look closely, is a living machine that has solved problems our engineers are still trying to copy. A punch that accelerates like a bullet. A club that survives hitting things hard enough to shatter glass. And a pair of eyes so strange that for years even scientists got the story wrong. Stay with me, because almost everything you have heard about this animal is half true at best. The real version is stranger. Let me start with what it even is. The mantis shrimp is not a true shrimp. It belongs to a separate, ancient group of sea creatures called stomatopods. Their line has been around for hundreds of millions of years, since long before the first dinosaurs walked the earth. They got the name mantis shrimp because they look a little like a praying mantis crossed with a shrimp, with folded front arms, held up and ready. There are hundreds of known species, scattered through warm, shallow seas all around the world, from bright coral reefs to plain muddy burrows. Most people will never notice one. That is part of the point. Most are small. The famous one, the peacock mantis shrimp, is rarely longer than your hand, and it is painted in colors that look almost cartoonish. Green, orange, electric, blue, and red. Beautiful. Easy to underestimate. And here is the first split you need to know. Mantis shrimp come in two basic kinds, based on how they kill. There are spears, with arms ending in barbed spikes, which they fire out to impale soft, fast prey like fish. And there are smashers, with arms ending in heavy clubs, which they use to crush hard armored prey like crabs, clams, and snails. The peacock mantis shrimp is a smasher, and the smasher is the one that performs the impossible. The spears are no less deadly in their own way. One sits hidden in its burrow, perfectly still, and when a fish or a shrimp drifts past, those barbed arms shoot out and skewer it before it can even register the danger. Same lightning speed, different tool. One kind impales, the other demolishes. But it is the smasher, with a hammer instead of a spear, that turned its own arm into something that seems to break the rules small animals are supposed to follow. So how does an arm that small hit that hard? Here's where it gets strange. A mantis shrimp does not punch the way you and I throw a punch. Your muscle pulls, your arm swings, and that is the speed you get. Muscle alone is simply not fast enough to do what this animal does. So the mantis shrimp does not rely on muscle for the speed. It relies on a spring. Inside that front arm is a small, saddle-shaped piece of the skeleton. The animal flexes its muscles slowly and bends that saddle, loading it with energy. The same way you bend a bow before firing an arrow or pull back a crossbow. A built-in latch holds everything in place, like the catch on a mousetrap, so the energy stays locked and loaded. Then the latch releases. All that stored energy unloads at once, and the club fires forward far faster than any muscle could ever move it. That is the secret. The mantis shrimp is not strong in the way we picture strength. It is a coiled spring with a trigger. Engineers actually have a name for this kind of mechanism. They call it a power amplifier. The idea is simple. Muscle is strong but slow. So instead of using muscle to move the club directly, the animal uses muscle to slowly load a spring, then lets the spring do the fast part. A mousetrap works the very same way. Your finger is far too slow to slam that bar shut on its own, but your finger can pull it back against the spring, and the spring snaps it shut in an instant. The mantis shrimp built that exact trick into its own body, millions of years before anyone ever designed a mousetrap. And when the trigger goes, the numbers stop sounding like biology and start sounding like a weapon. Let me give you those numbers, because they are hard to believe. The club accelerates at around 10,000 times the force of gravity. To put that in plain terms, that acceleration is on par with a .22 caliber bullet leaving the barrel of a gun. Read that again. A creature the size of your finger swings its arm with the same acceleration as a fired bullet. Now, I want to be careful and honest here, because the internet loves to overstate this. The club does not travel as fast as a bullet through the air. Its actual speed in water is somewhere around 23 meters per second, which is fast, but nothing like a bullet's flight speed. What matches the bullet is the acceleration, how violently it goes from still to moving. And that is what makes it so deadly up close. The strike lands with a peak force of around 1,500 newtons. That is more than 2,500 times the animal's own body weight, focused onto a point smaller than a fingertip. And it gets stranger, because the punch is only the first hit. When the club rips through the water that fast, it leaves a problem behind it. The water cannot move out of the way quickly enough, so it tears apart, forming a pocket of vapor. Scientists call this cavitation. For a split second, there's a little bubble of near emptiness in the water right behind the strike, and that bubble cannot last. It collapses in on itself almost instantly. When it collapses, it releases a burst of energy. A second shockwave slams into the prey, just microseconds after the club already hit. So the crab does not get punched once. It gets punched twice, by the arm and then by the water itself. And that collapsing bubble does something almost unbelievable for an animal this small. It gives off a flash of light, a spike of heat, and a sharp crack of sound, all in an instant too short for us to notice without instruments. Think about that for a moment. A small reef creature is generating light and heat with its bare arm, just by moving fast enough to tear the water apart. When I first read that, I genuinely thought I had misunderstood it. And here's the thing. None of this was even visible to science until fairly recently. The strike is far too fast for the human eye, so researchers had to film it with cameras, shooting many thousands of frames every second, then slow that footage down enormously just to watch a single punch unfold. Only then could they see the second hit, the collapsing bubble, and the flash of light. For most of history, people kept these animals, watched them smash shells and tanks, and never once realized that two blows were landing where they thought there was only one. So what does it do with all this power? It opens dinner. A crab's shell, a snail's shell, a clam shut tight. All of it is armor designed to keep predators out. The mantis shrimp does not pick the lock. It demolishes the door. It will hammer a snail shell again and again until the shell fails, then eat the soft animal inside. Armor that stops nearly every other predator on the reef is, to a mantis shrimp, just a puzzle that breaks if you hit it correctly. And there is the story everyone has heard. Mantis shrimp have cracked the glass of aquarium tanks. That part is true. It has really happened. But let me be fair about it, because the legend has grown taller than the truth. It is rare, and it usually involves a tank that was too small or too thin for the animal. A mantis shrimp is not going to explode through inches of reinforced glass. Still, the fact that it can happen at all, that a finger-sized creature can crack a glass wall with its arm, tells you everything about the force we are dealing with. If you are enjoying this, and you like the kind of story where the small, overlooked animal turns out to be a marvel of engineering, take a second to subscribe. Every week we go into worlds almost no one looks at twice, because the mantis shrimp is not done surprising you. The next part is the reason scientists and engineers are obsessed with it. Here is the puzzle that bothered researchers for years. If you hit things that hard, thousands of times in your life, why does your own weapon not break? You would think an arm that shatters snail shells would eventually shatter itself. Punch a brick wall enough times, and your hand is done. But the mantis shrimp keeps hammering, strike after strike, for its whole life. The answer is hidden in the structure of the club, and it is a small masterpiece of materials science. The club is not a simple solid lump. It is built in layers. The outer surface is arranged to spread the shock of impact across a wide area instead of letting it focus into a single crack. Beneath that, the inner layers are stacked in a slow spiral, each layer rotated a little from the one below it, like a twisting staircase of fibers. When a crack tries to travel through that spiral, it has to keep changing direction, and it loses energy at every turn. The crack gets tangled and trapped before it can split the club apart. That design is so good that human engineers are now copying it. Researchers are studying the mantis shrimp's club to build better body armor, tougher helmets, and stronger materials for aircraft and cars. A reef animal smaller than your hand is teaching us how to make things that do not break. It solved a problem in impact resistance that our best labs are still working on, and it did it millions of years ago, without a single engineer. Now we get to the part of this animal that almost everyone has heard about, and almost everyone has wrong: the eyes. You have probably seen it claimed online. The mantis shrimp has the best color vision on the planet. It sees colors we cannot even imagine. It has a rainbow superpower locked inside its head. It is one of the most repeated facts about this animal, and it is wrong. Here is what is actually true. The mantis shrimp has the most complex eyes we know of. A human eye has 3 types of color receptor: red, green, and blue. From those 3, your brain builds every color you have ever seen. The mantis shrimp has 12 color receptors and up to 16 photoreceptor types in total. On paper, that sounds like it should see 4 times the color we do, an explosion of shades beyond human imagination. But that is not how it works. In 2014, scientists actually tested it. They trained mantis shrimp to recognize colors and then checked how finely the animals could tell similar shades apart. And the result stunned everyone. The mantis shrimp was worse at telling colors apart than a human. Not better. Worse. So why have all those receptors? Because the mantis shrimp does not see color the way we do. Your brain compares signals from your 3 receptors very carefully, which is slow but precise. The mantis shrimp does not compare, it scans. Each of those 12 receptors reports a slice of the spectrum, and the animal recognizes color almost instantly, without the careful mental math your brain performs. It trades fine detail for raw speed. It is not better vision. It is an entirely different way of seeing, built for an animal that needs to make snap decisions in a fast, dangerous reef. And it gets stranger still. The mantis shrimp can see something no human ever will. It can detect polarized light, including a twisting kind called circular polarization. As far as we know, it is the only animal on Earth that can see circular polarization at all. Some researchers think the mantis shrimp uses this as a private channel, a secret code. Their own bodies reflect this twisting light, so 2 mantis shrimp may be able to signal each other in a language that is completely invisible to predators, to prey, and to us. So the real story of those eyes is not more colors. It is a hidden, secret form of sight we cannot share. But even a weapon like this has one moment of weakness, and it is a serious one. Like all crustaceans, a mantis shrimp grows by molting. Every so often it sheds its entire hard shell, including that incredible club, and crawls out soft, pale, and new. For several days, while the fresh shell hardens, the spring will not work. The club is too soft to fire. The most heavily armed animal on the reef suddenly cannot throw a single punch. During that window, it does the only smart thing it can. It hides. It seals itself deep inside its burrow, plugs the entrance, and waits, completely defenseless, until its weapon hardens again. Picture that. A creature that can crack glass, curled up in the dark, unable to defend itself at all, hoping nothing finds the door. The fiercest fighter on the reef spends part of its life utterly helpless. Which brings us to the question in the title. What are mantis shrimp for? What kind of life needs a bullet-fast punch, a self-healing club, and secret vision all at once? The answer is a life of constant combat. Mantis shrimp mostly live alone, each one guarding a burrow or a crevice in the reef. They are fierce and territorial. They will defend their home against anything, fight rivals over space, and attack with that club at the smallest provocation. Some have even been seen striking at their own reflection in the glass of a tank, attacking a threat that is only themselves. In a crowded, brutal reef where everything is trying to eat everything else, the mantis shrimp chose to become the thing nobody wants to fight. So let us go back to where we started. A creature the size of your finger, painted like a toy, sitting quietly in a reef. You know now what is really inside it. A spring-loaded arm that fires with the acceleration of a bullet. A double strike, the club, and then the collapsing water behind it, complete with a flash of light and a crack of sound. A peak force thousands of times its own body weight. A club so cleverly built that it shatters armor without shattering itself, and now teaches our engineers how to do the same. And a pair of eyes that do not see more colors than we do. but instead see in a faster, stranger, hidden way that no human ever will. That is the real lesson of the mantis shrimp. The most extreme animal in the room is not always the biggest or the most dangerous looking. Sometimes it is the small, bright thing in the corner that quietly out-engineered the entire ocean. So here is my question for you. If a creature this small can break our myths about its own eyes and beat our best armor with a spiral of fibers, how many other animals have we completely misunderstood just because they were too small to take seriously? If this changed the way you see the mantis shrimp, subscribe. Every week we go into worlds almost no one looks at twice. And if you ever stand in front of a reef tank and spot a flash of green and orange watching you from a crevice, look closer. You are looking at one of the best weapons evolution ever built.